The distance formula. So the distance formula is a way to find the distance between 2 points. Now, when we find the distance between 2 points, it's tempting to just say, okay, 1 and 6 are 5 away, and 3 and 5 are 2 away, so it's 7. 5 plus 2 is 7. But that's not correct. So this distance being 2, and this distance being 5, we can't actually say that this is the shortest path. I can draw a shorter path between the blue dot and the red dot, which is this diagonal path. And the thing is, this is a right triangle, so we can use the Pythagorean theorem. The Pythagorean theorem states a squared plus b squared equals c squared, where a, b, and c. So 2 squared plus 5 squared equals c squared. That's 4 plus 25 equals c squared. So 29 equals c squared, and c is the square root of 29. So the distance here is square root of 29, and that's perfectly fine to leave as your answer. So that's what I just did. The Pythagorean theorem allows you to draw a right triangle, label the lengths of the legs, and use Pythagorean theorem. So here's another one. Let's draw the right triangle. So we go from here to the right, and then make the right triangle. How far is this from -2 to 3? Well, that's 1, 2, 3, 4, 5. From 1 to 8, well, 8 minus 1 gives us, this is a distance of 7. And because this is a right triangle, we can do Pythagorean theorem with 5 squared plus 7 squared equals our distance squared. I'm going to use d just because we're calculating distance. So 25 plus 49. 25 plus 49 is 74. And d is the square root of 74. Now, things become more confusing when we have variables instead of numbers, but the process is still the same. We still want to take this distance to the right, and the distance to the right is, well, however far this x2 is, minus however far this x1 is. That's that length. That's what we talked about before, that traveling from left to right was just taking the x-coordinates and subtracting them. This distance is about changing y. Here, y is how high up it is. So if we subtract the y-coordinates, y2 minus y1, then we get these lengths. Now we can do Pythagorean theorem with that idea. So x2 minus x1 squared plus y2 minus y1 squared equals our distance squared. So if we want to find what the distance is, the opposite of squaring is square rooting. So this is a formula that we are allowed to use. And this is called the distance formula. This is a big deal, and I'll put it on the slide, next slide. That is the distance formula. Distance equals the square root of change in x squared, so x2 minus x1 squared, plus y2 minus y1 squared. X1 and y1 have to come from the same point. X2 and y2 have to come from the same point. So if we wanted to find the distance between s and u, yeah, we could do the first way, but let's try doing this with the distance formula method. So this is -5, 3, and this is 2, 6. So if we take the distance, that would be the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, here's x1, here's y1, here's x2, here's y2. Now we substitute in. x2 is 2, x1 is -5, y2 is 6, y1 is 3. Now 2 minus -5 is 7, 6 minus 3 is 3, Squaring them gives us 49 plus 9, square root of 58. And that's our answer. Now, you might argue that it's easier to do this with Pythagorean theorem, but when you don't have a coordinate plane and when you just have the points, it's much easier to just substitute in. So you have to know the distance formula. Distance is square root of x2 minus x1 squared plus y2 minus y1 squared. That's the formula. Now x2 is the second x-coordinate. x1 is the first x-coordinate. Y2 is the second y-coordinate. And y1 is the first y-coordinate. Notice that because this is -7, I'm plugging in -7. So minus was already there, minus -7. So 3 minus 1, 3 minus -7. Now we do 2 squared and 10 squared, and that gives us square root of 104. Now, if you don't know how to simplify that yet, we'll worry about that later. This is slightly bigger than 10, but a better answer for sure would be if you know how to simplify your radicals, then we would simplify this as 2 square roots of 26, and that would be our better answer, 2 square roots of 26. Thanks.